Hello everyone, I am Stefanos Koutoupis and today I will present our work titled The More the Merrier Contrastive Fusion for Higher Order Multimodal Alignment. Multimodal data naturally co-occurs in the world. For example, image-text pairs, audiovisual pairs, and other multimodal combinations naturally occur at large scale and can often be collected without expensive manual annotations. Recent contrastive learning methods such as CLIP have shown that we can learn powerful representations simply from co-occurrence between modalities. These approaches align paired modalities in a shared embedding space using contrastive objectives like info and C. This paradigm has been extremely successful and enabled many downstream applications. However, most existing methods rely only on pairwise relationships between modalities. This creates an important limitation. Pairwise alignment assumes that discriminative information is already available between modality pairs, but in many real-world settings, useful information only emerges when multiple modalities are combined together. For example, similar bird species may be difficult to distinguish using images alone. So, while pairwise information is sufficient for many tasks, there also exists synergistic information that is only available jointly across modalities and is not captured by pairwise alignment. Our goal is therefore to build a unified framework that preserves pairwise alignment while also capturing higher-order interactions between modalities. To illustrate the limitations of pairwise learning, we follow the XOR-style experimental setting introduced in prior work, where the target information is only recoverable through the joint interaction of multiple modalities. In this case, pairwise methods collapse to a chance-level performance. This motivates our method called CONFU, short for contrastive fusion. The key idea behind CONFU is to jointly model traditional pairwise dependencies and higher-order multimodal dependencies. We formulate this using a decomposition of total correlation where mutual information terms are approximated using info and C objectives. CONFU therefore supports both standard 1-to-1 alignment and higher-order 2-to-1 alignment objectives. Let us now look more closely at the CONFU framework. Each modality first passes through its own encoder and projector into a shared embedding space. We then optimize two types of objectives. First, we apply standard pairwise info and C losses between modality pairs to preserve conventional alignment. Second, we introduce higher-order alignment objectives. Here, fused representations from two modalities are aligned with the remaining modality using another info and C objective. The final training objective combines these pairwise and higher-order terms into a unified contrastive learning framework. We evaluate CONFU on several standard multimodal benchmarks, including AVM-NIST, MOSIS, MASTARD, and YourFunny. We evaluate across multiple settings, including retrieval, zero-set classification, and linear probing. In addition, we perform a large-scale transfer evaluation using our proposed BirdMML dataset, where models are pre-trained on image audio text triplets and evaluated on downstream audiovisual bird classification tasks. We also introduced a new dataset called BirdMML. BirdMML contains around 149,000 image audio text triplets across 150 bird species. It was specifically designed to evaluate multimodal complementarity and higher-order interactions. The dataset combines images from MyNaturalist, audio from Zenocanto, and textual information from Wikipedia. We additionally synthesize captions that combine visual, acoustic, and textual information into unified multimodal descriptions. Across benchmarks, CONFU achieves performance comparable to or better than prior methods, while supporting both pairwise and higher-order alignment in a single framework. When pre-trained on BirdMML and evaluated on downstream bird classifications, such as SSW60 and VB100, CONFU particularly excels in audiovisual zero-set classification. Importantly, it remains robust even when one modality becomes weak or uninformative. To conclude, we introduced CONFU, a unified contrastive framework for higher-order multimodal alignment. Our method jointly models pairwise relationships and synergistic multimodal interactions within a single contrastive learning framework. We also introduced BirdMML, a new multimodal triplet dataset designed for evaluating multimodal complementarity. Overall, our results demonstrate improved robustness and strong multimodal performance across a variety of tasks. Be sure to check out our paper. Thank you for your attention.